Hi everyone, this video is on exercise 12 by question 7. So we have the function f of x and we want to find the coordinates of the stationary points of f and then determine the nature of the stationary points. So to find the stationary points, we first need to differentiate this function and then set the derivative equal to 0 so that we can find the x coordinates of the stationary point. So the first derivative here is equal to 4x cubed plus 9x squared minus 10x minus 3. And to find the stationary points, we need to solve f dash x is equal to 0. So that means 4x cubed plus 9x squared minus 10x minus 3 is equal to 0. So this is the cubic, and we can't factorize this easily. But what we can do is using the factor theorem. So we need to guess one of the solutions, and then we can use that and the long division to find a quadratic that can be solved and find all the solutions here. So the first guess is always 0, but the problem is when we find f of 0, we are going to get positive 1, so that's not going to work. But let's try f of 1 and see what happens. So f of 1 is equal to 1 plus 3 minus 5 minus 3 plus 1. Sorry, I substituted in the wrong equation because remember that we need to substitute this into the equation of the first derivative, not the f of x. Yeah. So, but regardless of that, even if we try 0, we are still going to get a non-zero answer, which is minus 3. So it's minus 3 is not what we want. So let's try f dash of 1. So we are going to get 4 plus 9 minus 10 minus 3. So as you can see, they cancel each other out and we are going to get 0. So 1 is one of the solutions when x is equal to 1. So when x is equal to 1, f dash 1 is equal to 0. So one of the solutions is x is equal to 1 is a root. So we can use this at the factor theorem so that we can use the long division to find the other solution. So I'm going to use the long division now. So 4x cubed plus 9x squared minus 10x minus 3 divided by x minus 1. So it's always x minus the root that you find by the factor theorem. So in this case, we just need to find, so the first one is obviously 4x cubed. So that's the first term because, sorry, 4x squared, because that gives us 4x cubed here. So we need to choose some terms such that they are equal to each term of here. So, and then 4x squared times minus 1 is minus 4x squared. So remember that we always subtract these. So the top one minus bottom one gives us 0 for the cube terms, and then 9x squared minus 4x x squared is 13x squared. And then we bring every other term down, so minus 10x minus 3. So now we choose 13x because that gives us 13x squared minus 13x. So we subtract, and here is 0 for x squared terms. For x terms, we get positive 3x minus 3. And finally, we just use 3. That gives us 3x minus 3, and we get 0. So the quadratic, so we can rewrite the function, which was or actually the equation. So the equation was 4x cubed plus 9x squared minus 10x minus 3 as x minus 1 times the quadratic that we got. So 4x squared plus 13x plus 3. Now, in order to find the rest of the solutions, we can solve this quadratic. So 4x squared plus 13x plus 3 is equal to 0. And if we solve this quadratic, then the roots of the quadratics are these two. So I'm not going to solve this quadratic, but the roots are minus the fourth and minus 3. So, and also remember that one of the roots was 1. So let's call this x1 just to keep track of the roots, this one x2 and x3. So now we have all the roots, so we can then find the corresponding stationary point of each of these by substituting the x coordinates into f of x. So that means when x is equal to 1, then f of x is minus, so f of 1 is equal to minus 3 when x is equal to minus a 4. F of x is, f of minus 1 over 4 is equal to, it's 357 over 256, so not the nicest number. And finally, when x is equal to minus 3, f of minus 3 is minus 35. So these are the three stationary points. So the stationary points are, these are the stationary points with the coordinates 1 minus 3, minus 3 minus 35, and finally minus a fourth, 357 over 256. Okay, now that we have the stationary points, then we need to determine the nature of each of these. So we find the second derivative. So the second derivative is equal to, this is the first derivative, so that's equal to 12x squared plus 18x minus 10. So we get 12x squared plus 18x minus 10. And all we need to do is that just substituting each of the x coordinates of the stationary points into f double dash x, and then we can determine the nature. So for example, f double dash of 1 is greater than 0. So that means the stationary point 1 minus 3 is a minimum point. So f double dash of minus 3 is greater than 0, so it's again another minimum point. So that means minus 3 minus 35 is a minimum. And finally, f double dash of minus a fourth is less than 0. So minus a fourth, 357 over 256 is a maximum point. So now that we have determined the nature of each of the points, remember that we want to sketch the graph of y is equal to f of x. But it's not going to be complicated at all, because all we need to do is using the stationary points to sketch this. So when we have the stationary points, it's very easy. And also remember that we have a positive function. So it's going to look like something like this because it's positive, this function. Okay, so now in terms of the stationary points, obviously one of the stationary points is minus 3 minus 35, which is, let's say, around here. So this is not going to be accurate. One of the other stationary points is 1 minus 3. So it's roughly here. And then the other stationary point is minus a fourth. And then it's it's around here, 357 over 256. So it's 1 point something. And also to check the y-intercept, that's 1. So the y-intercept is here. And we know that this graph is positive. So this curve is going to look like this. Yeah, let's try again this part of that. So yeah, it's going to look like this. Note that as we discussed, the point minus 1 over 4 is a maximum, so that's why it goes down, but the other 2 points are minimum. Yeah, so this is a very rough sketch of the graph. And that's it for this video. Thank you for watching.